Hey guys, welcome to my video. This is Saritha. Hope you are all doing well. So recently KVPY examination is held and after a long delay. So today in my video, I'm going to discuss some of the memory based questions. At the end of the video, if you feel the content is useful to you, please like, share and subscribe to my channel. So without wasting much time, let's learn the questions. So the question is x bar 6 minus 6x bar 5 plus 15 x bar 4 minus 20 x cube plus 15 x square minus 6x plus 1 is equal to 0. To this equation, a is assumed to be smallest root and b is assumed to be the largest root. Then find the value of a square plus b square divided by a plus b plus 1. So basically this equation is a 6th-degree equation and it has 6 roots. So when I looked at the coefficients, 1, 6, 15, 20, irrespective of the signs, 15, 6 and 1. So these coefficients are same, equidistant from the beginning and from the end. So this makes me recall about Pascal's triangle. So the whole of this expansion with alternate plus minus signs can be written as x minus 1 whole power 6. If we remember the binomial expansion, it starts from 6a0 x power 5 minus 6a1 x power 6, 6a1 x power 5, and plus 6c2 x power 4 minus 6c3 x power 3 plus 6c4 x power 2 minus 6c5 x plus 6c6. So when we looked at this, this equation is identified to be x minus 1 whole power 6. That means this has all equal roots. So a will also be 1 here and b is also 1 here. So the value of a square plus b square by a plus b plus 1 is equal to 2 by 3. Another question is find the number of integers n such that n plus 3 divides n cube minus 3. So we know that n cube plus 3 cube is exactly divisible by n plus 3. So to n cube minus 3, we can add and subtract 3 cube. So after splitting, n cube plus 3 cube is exactly divisible. So this division will leave some integer. And other expression what we have is 30 divided by n plus 3. Now 30 should be exactly divisible by n plus 3. So if n plus 3 is one of the divisor of 30, the number of divisors of 30 here are 30 can be expressed as 10 times 3, which is 2 times 3 times 5. So total number of divisors what we have is 8, because each prime power is 1 here. So 8, this is about the positive divisors. But since n can be in integers, we do have 8 negative divisors also. So totally n values can be 16. Another question is, sum of the sides of the right angle triangle is 42. Difference of the median in the altitude and hypotenuse is 2. Find the area of the triangle. So if we can construct a right angle triangle here and denote the vertices by A, B, C. Let's say this is the median, BD, and this is the altitude, which is BE. So we know that AD will be equal to CD will be equal to BD, since D is a circumcenter. So generally circumradius is denoted by capital R. Let's say this is R and this is also R here, and then even BD is also R. And let us assume this to be some X. So area of the triangle, if I'm assuming the BE to be height, it will be half times the base into height. But the same area can also be calculated using properties of triangles, where delta is equal to RS. R is the end radius, S is a semi-perimeter. And R also, according to the information what we have, based on that, if I take S minus B into tan B by 2 times S. So here S is 21 because the sum of the sides of the right angle triangle is given as 42. So it should be 42 by 2, which is 21. So it's 21 minus 2R into tan B by 2 is tan 45 times 21. And here I can write X as, since the difference between the median and the altitude is 2 here, R minus X is 2. So X will be R minus 2. So upon solving this equation, which is a very simple quadratic equation, R will come out as 9. So when R is 9, it's easy to find out X as well as the delta. So delta, you can write it as Rx, which is 9 times. X will be here R minus 2, which is 7. 63. The next question is, if we have the numbers 1, 2, 3, 4 till n are written on the board, a random number k in between 1 and n is erased, then the average of the rest was given 16. Find the value of n plus k. So the average after a number k is removed is nothing but 1 to n minus k divided by n minus 1 is equal to 16. So on solving this equation, we know the sum of the numbers from 1 to n is n into n plus 1 by 2 minus k is equal to 16 times n minus 1. N into n plus 1 by 2 minus 16 times n minus 1 is equal to k. And since k is a number which is picked from 1 to n, k will be any number lying between 1 and n. But the simplified form of the k here is n square plus n minus 32 times n minus 1 by 2 should lie between 1 and n. So further simplifying this, 2 lesser than or equal to n square minus 31n plus 32 is less than or equal to 2n. So on solving one of side, n square minus 31n minus 2n plus 32 is less than or equal to 0. So this equation has two roots and it's lesser than or equal to 0. N square minus 33n plus 32 is less than or equal to 0. So the roots of this equation can be 32 and 1. where the sum of the roots becomes minus 30 plus 33, product of the roots will be 32. So n belongs to 1 to 32 is a solution for this. On the other side, if I'm solving n square minus 31 n plus 30, it's greater than or equal to 0. And here the roots are 30 and 1. And n should be n minus 1 into n minus 30 should be greater than or equal to 0. So this gives a solution n belongs to minus infinity to 1, union 30 to infinity. So common solution where n can belong is 1 to 30 to 32. So n is a value which can lie between 30 and 32. And we also have the simplified form of k, which is n square minus 31n plus 32 by 2. So now here, if you plug in k as 30, n as 31, k comes out as 16. So the value of n plus k is 47. But since both of them have to be an integers here, we can try plugging in all the values of n lying between 30 and 32. But n is equal to 31 gives you k is equal to 16. The next question is number of positive integers satisfying 1 by x plus 1 by x plus 1 plus 1 by x plus 2 is equal to 13 by 12. So LCM of three consecutive numbers, three consecutive positive integers should come as 12. And so the only way those numbers can be chosen is like when x is equal to 2. 2, 3, and 4. LCM is going to give us 12. So and 1 by 2 plus 1 by 3 plus 1 by 4. So sum is going to give us 13 by 12. Suppose if we think of higher values, let's say x is equal to 3. So as you increase the x value, the denominator is going to increase and the LCM will not come as 12. So x is equal to 2 is the only value which satisfies this equation. Let's see another question. In a triangle ABC, O is the circumcenter and I is the incenter. BCIO is cyclic. Find angle B plus angle C. So let us construct a triangle here. Let's say this is a triangle ABC. With vertices ABC here. Incenter lies on angle bisector. Circumcenter lies on side bisector. So, but given that BCIO is on cyclic. So that means BCIO lie on a circle. And suppose the angle at O if I wanted to find. So I'll join this. Angle at O if I want to find. We know that angle on the circumference and angle at the center for circumcenter, it is BOC is 2 times A. Now, if I wanted to find out the angle BIC, angle BIC is nothing but 180 minus angle IBC plus ICB. Since I is in center, these angles are B by 2 plus C by 2. And we can also write 180 as A plus B plus C by 2. So over a B by 2 plus C by 2 is nothing but 90 minus A by 2. So we get 90 plus A by 2. Suppose if I am drawing a circle which is passing through B, C as well as O and I. And BC becomes a chord here. Chord subtends equal angles on the circumference. Since I is a point on the circle as well as O is a point on the circle, chord subtends equal angles on the circumference. So we can equate 90 plus A by 2 is equal to 2 times A. So this would give us 90 is equal to 2A minus A by 2, which is 3A by 2. So angle A comes out as 60 here. So, and A plus B plus C, we know that it's 180. And when angle A is 60, B plus C will be 120. Let's discuss the next question. Ordered pairs A comma B such that A minus B is the root of the quadratic equation x square plus AX plus B is equal to 0. Any root will satisfy its own equation. So let us plug in A minus B whole square plus A times A minus B plus B is equal to 0. So on simplifying this equation, you get 2A square minus 3AB plus B square plus B is equal to 0. And there's a condition to be mentioned here that A comma B are integers. If A comma B are the integers, then when we are solving this quadratic, which is in terms of A, we can write it as 3B plus or minus square root of 9B square minus 8 times B square plus B divided by 4. So for B, for A to be an integer, the expression under the root should be a perfect square. So B square minus 8B should be a perfect square. So how many values of B will give you the lambda here, that we need to check. By completing the squares here, we get B minus 4 whole square is equal to lambda square plus 4 square. So when we look at such equations, we will think of triplets, which are the sides of the right angle triangle, Pythagorean triplets. So one of the lambda value can be plus or minus 3. And when lambda is plus or minus 3, B minus 4 will be plus or minus 5. Other value of lambda which we can get it is lambda is equal to 0, then B minus 4 is equal to plus or minus 4. So this way we get the B values as negative 1 comma 9 and 0 comma 8. So the corresponding A values and the ordered pairs, when we plug in the above equation, we get origin as one ordered pair, 0 comma minus 1 and 6 comma 9 and 6 comma 8. So there are 4 ordered pairs which satisfies this condition. The next question is find 2-digit numbers such that AB is equal to 4 times A factorial plus B factorial where A and B are the digits of two-digit number. So if we rearrange and write this expression as AB divided by 4 is equal to A factorial plus B factorial. Any factorial is going to be always an integer. So right side, it's sum of two factorials. It's purely an integer. So left side, it becomes an integer only when AB is a multiple of 4. So possible numbers for AB are like 12, 16, 20, 24, 28. I have to write these numbers less than 100 because it's a two-digit number. So what is the last number less than 100 which is divisible by 4? That is 96. Apart from that, like we need to check the condition that the picked number also satisfies A factorial plus B factor. Let's say we are taking up 12. 12 divided by 4 gives us 3. And A is 1 here and then B is 2 here. Thus 1 factorial plus 2 factorial gives us 3. So 12 is one of the right number. And when we pick up 16 here, 16 by 4 gives us 4. But 16 factorial is going to be a huge number. So we can come to a conclusion whenever the second digit is higher, it will not satisfy the above condition. So you can check for 20. It is, although it is divisible by 4, but it cannot satisfy the A factorial plus B factorial condition. So when we keep checking it for all the values, there is another number 32. 32 divided by 4 is 8, and that is also equal to 3 factorial plus 2 factorial. So the only two possible numbers which satisfies a given condition are 12 and 32. Let's see the next question. The work is done by company A and B. A can complete the work in 9 days and B can complete the same work in 18 days. A started the work in 2 days and then B joined. They were together for 4 days and then A left. Then B was asked to increase its efficiency to twice. Determine how many days are required to complete the work. So A's 1 day work is 1/9. Since A started with the work for 2 days, it's 2 times 1/9. And then B joined. B's 1 day work is 1/18. And they were together for 4 days. So it's 4 times 1/9 plus 4 times 1/18. A and B both together worked for 4 days and A left. And B was asked to increase its efficiency by twice. Let's say B took X number of days to finish that work and its efficiency is increased to twice. So it's 2/18 and all of this sum should be equal to 1. So on solving this equation, so it's 2/9 plus 4/9 plus 4/18 plus 2x/18 is equal to 1. So further simplify this. Two by 9 plus 2/9 is 4/9, 8/9. So it should be 8/9 here. So on solving this equation, we get x is equal to 1. So the number of days required to complete the work is 1 day. Let's see the next question. In convex quadrilateral ABCD, AC is equal to BD, AB is equal to CD. Angle ABC is 50, angle ACB is 40. Find the acute angle between AC and BD. So the information given in this is angle ABC is 50. Let's say if I'm constructing a normal triangle ABC, if B is given as 50, that means A is given as 40. The third angle should be 90 here. So that means ABC is a right angle triangle. Let's construct the right figure. This is a right angle triangle where at angle A it is 90, at angle B it is 50, and at angle C it is 40. So another condition which is given is AC is equal to BD. So generally AC and BD forms at diagonals of that quadrilateral, and I need to construct a line such that AB is equal to CD and then join BD. So in this figure, this side is equal to this side, that is AB is equal to CD given, and also this side is equal to this side. So if you look at these two triangles, ADC and DAB are congruent. AD being the common side to both. So if we can apply that property, the angle at this point should be equal to angle at this point. And if these two sides are equal, angle at this point will become 40 again. So this angle will be 10. Since this angle is equal, I don't think we can take this. Since we need the angle between AC and BD, we know that this part is 10 and this is 90. So this angle, let me assume this point to be some E. Angle AEB is 180 minus 50, 90 plus 10, which is going to be 80.